Hello and welcome back to the DIF from the Ellen MacArthur Foundation. We're here on day one and my name is Joe and I'll be taking you through this conversation about biomaterials over the next half an hour. The way that we make stuff and what we make it from fundamentally has to change. So in the past, we've taken stuff out of the ground, we've turned it into some weird and wonderful products, and then we've chucked them away. And that's what we at the Ellen MacArthur Foundation call the linear economy. But we know it can't work like this forever. And some people think that more stuff should be grown rather than mined. But it's not a silver bullet. We already grow a lot of stuff, mostly food. And the way that we do it results in massive negative impacts for people and for the environment. So it's a pretty tricky topic. To help us work through it today, we're joined by two people from Metabolic, a consultancy and think tank that uses systems thinking to tackle global sustainability challenges. So joining us at the DIF today are Liz Corbin, Research Director at Metabolic, and Brian Shaw, Agri-Food Systems Consultant, also from Metabolic. Hi, guys. Great to have you here.
Hey, Joe.
Great to be here.
A quick reminder for the audience watching at home, do send your questions in. Biomaterials, food versus organic materials for other products. These are all going to be pretty tricky topics. So send your questions in, whether you need something clarified or you've got a question for Liz and Brian. Use the chat box and we'll get to your questions throughout the session. So Brian and Liz, people have a hard enough time understanding the economy. So what about the bioeconomy? Can you help us figure out what that is?
Yeah, sure, Joe. So the bioeconomy essentially those parts of the economy that rely on renewable bio-based processes to provide food, materials, energy, chemicals, and other things that we need as a society. As you said already in your introduction, of course, the bioeconomy has been around for a long time, and primarily what we have used the bioeconomy for has been the production of our food and also our textiles, things that we wear, also housing. And why it's a hot topic now, why we're all here today, is because for sustainability objectives, to reduce our reliance on fossil fuels, we're increasingly looking to substitute fossil-based materials out of our value chains and substitute bio-based materials in.
So just to clarify, we already have a bioeconomy. So it's not something that's a future sort of end state. It already exists around us. But what we're talking about now is that it's changing. So the amount of stuff that is in that bioeconomy or the types of things in that bioeconomy, they're undergoing some sort of shift. Is that fair to say?
Yeah, I would say it's the pressure is changing maybe. So like Brian said, the biggest industry in our bioeconomy for hundreds of years now has been how we feed ourselves. But also imagine we've always made houses out of timber, or many of us in many parts of the world. Some of us are wearing products from the bioeconomy, whether it's silks or cashmere, like I'm wearing today, or cotton or so on. And what we're looking into quite a lot here at Metabolic is how trends inside some of our more higher impact industries are shaping the possible future trajectory of this bioeconomy, and how we can mitigate certain pressures from bottling up, I guess, in terms of how we manage competing demand for these resources.
Okay, so we'll get into some of those competing demands, and we'll explore that a bit in a moment. But just because I know we're going to be using certain types of words a lot throughout this session, I'm not asking for a glossary here, but some of these terms are really confusing, or sometimes they seem contradictory, or things like compostable bio-based. We've already had bio-benign, I think, renewable, organic. Like these terms, there's a lot of them. Sometimes they're a bit tricky to get your head around. Which are the things that we really need to know, and what do they mean?
Yeah, I would say that's actually a key question for us in our work is as well. I mean, I think a lot of the confusion around this space is a product of a lack of clear terms and definitions across these different industries. So, for example, a bio-based material could be anything from a material that's made 100% from a plant-based stock like cotton, right? A 100% cotton t-shirt is a bio-based material made from a bio-based fiber that is a bio-based product. However, you could also have a carpet tile that has 2% of a cotton or soy, and 98% a synthetic substrate. And at the moment inside our industries, we're not regulating what each of these terms are and how they're defined and how they're benchmarked. So currently that is equally a bio-based material, and that has huge implications in terms of how companies can market themselves, how consumers understand or misunderstand the composition of the products that they're buying, and also how we can manage these materials at the end of their life. What can safely degrade in soil at the end of its life to the fullest extent without harming the surrounding environment? What could dissolve in marine-based habitat or freshwater without harming anything? It's very difficult at the moment. That part of the academic community and the commercial sector, I would say, is really underdeveloped, and that's a key part that we can talk about today, about how do we troubleshoot that, and how do we kind of start working together more to bring greater clarity around these terms.
Okay, so I think we'll come back to that one, and a shout out to the people watching. If there are certain terms that you want defining or you want us to discuss that you're stumbling on, put them in the chat, and we'll discuss them with Liz and Ryan. I want to get into the advertised topic here around this kind of food and other bioeconomy uses or materials. So can you sum up that tension? That is it that we already grow loads of stuff for food, now people want to grow more biological materials for other uses, so we're running out of land, using too much energy? What's the problem there?
Yeah, I mean, Joe, I would say that primarily the problem statement is that for the production of our food right now, the environmental cost of this is biodiversity loss, eutrophication, so poisoning of rivers and lakes and oceans. It is ocean pollution. It's something around 30% of climate change. The production of food is the largest user of fresh water, often in competition for other uses. And if we're going to produce up to 40% more food, which is what we need for a growing population, add to that an increasingly wealthy population with more resource demands, add to that the pressure of substituting biomaterials for fossil materials, then we have to really ask ourselves, can we really produce all of these materials in a way which maintains the integrity of our ecosystems, which are actually supporting the production of these materials? So we could, in principle, reach a point where we lose the resilience or our ability to produce these materials, including food, for ourselves. And this is a very, very tricky conundrum.
So should we, a simplistic response would be, well, let's not produce more stuff let's not grow more things. If we already admit that the way that we produce food is incredibly wasteful and polluting, all those problems that you just described, it sounds like we shouldn't be moving more stuff to that way of growing things.
I think that there's a lot of opportunity to improve in this space. It's not, I mean, of course we need to produce food. This is the big challenge, that we need the food. We also need the materials if we're going to wean ourselves off fossil fuels, and if we're going to do better with climate change. So it's not about not producing and not substituting. It's about doing it smarter. It's about reducing the impact. And there are lots of ways out there, and there's a lot of initiatives out there that can help us do this, but we really need to change the system. We need to transform the system and how it's producing and distributing food. And we can talk about a lot of the different options there for where we can make these interventions to do it in a better way.
Well, maybe you could give us a few examples then of what you see as some of the bright spots for new ways of practicing new agricultural practices, whether that's for food or for other types of non-food products. What are some of the bright spots? So
I could definitely talk about agriculture, but I would say only this, that to anybody tuned in, stay for the next session, because a good friend of mine, Felipe, will be talking about regenerative agriculture and regenerative agroforestry. And these are production systems which really have a lot to offer in terms of protecting biodiversity, minimizing water use, being climate friendly, meaning that they're actually sucking carbon out of the air. So these things at the practice level are very, very important to be deployed and to be picked up and scaled up across the board. But what I would talk a bit more about is actually what we need is coordination in our production. So whatever the systems are that we use, we need to make sure case by case, water basin by water basin, field by field, forest by forest, that we know what is the optimal system to use in that place to produce the materials that we can whilst maintaining that integrity. So there's an organization that we're working a lot with at Metabolic. It's called the Science-Based Targets Network. And that's trying to set targets, like I said, in a contextual way for the production of materials, which is then understanding this production in the context of limits. So how much can we produce? And let's coordinate across sectors and get buy-in from the private sector to say that we will observe these targets. We will set them as goals for our companies. And the idea is hopefully all of this aggregates up to something which is maintaining a safe operating space for everybody.
Okay, I get from that the systems change piece is really important, and we, as we said at the start, Metabolic's all about systems thinking, and which can be kind of paralyzing. I've heard this quote in different forms, that technological change moves faster than systems change, and there's loads. I mean, Liz, we've spoken at the DIF before about material innovation, and this stuff moves pretty fast. How can you balance the two, that someone in a lab somewhere is cooking up the next miracle material, but they might not give a hoot about if the system's ready for it or not?
Yeah, and I think a lot of what's to be done there too is we have people from many different walks of life. We have scientific lab-based material scientists and engineers. We have kind of academics looking at new business models for circular economy businesses. We have people all across all of our industries working on this too, whether it's startups or SMEs or large corporates. And what we're seeing too is this is kind of bubbling out of just being an agri-food conversation to being much more cross-sectoral. So now the chemicals industry, key players within the chemicals industry, where trends are projecting a rise between 5 to 22% of all chemicals globally as a market share will be bio-based by 2025. That's a really fast, really high spike. We're also seeing biomaterials for product design and industrial design, more and more biomaterial development in textiles and so on. And I guess what I would say is we need to work together to think in a little bit more of a sophisticated way about the different generations of biomass and what type of generation might be best to use for what type of economic use. And by generation, I mean, so we have primary biomass, right? Which is the actual crops that we grow, and we're pulling different types of algae out of marine habitats, and we're farming meat and so on. All of these things are our primary biomass. And then we have second and third and fourth generation. So second generation is immediate byproducts from that industrial agri-food system. So you can think of orange peels, right? Like the peels of, literally just the peels of an orange, that is already second generation biomass because it's a byproduct of the juice industry. Third generation is post-consumer waste. So when you throw away that cotton t-shirt or your vegetable peels or so on, even human waste is considered third generation. And then we have fourth generation, which is actually literally pulling carbon and producing fuel and chemicals principally from that carbon of waste, of off gases from different industries. So it's producing fuel and chemicals from basically carbon monoxide and carbon dioxide. What's happening at the moment is the bulk of our bio-based economy is actually all coming from primary feedstocks. And that's kind of a quintessentially non-resilient system because we're all competing for only one portion of this pie, right? So in Europe, the JRC just did a report saying in Europe, in an annual basis, we consume 1.2 billion tons of biomass. And that's about half is taken up from feeding animals and then feeding us. And the other half is split across energy, so fuel, and then biomaterials within textiles and product design and the built environment and so on. Now, 1 billion of that is taken from primary feedstocks. So if we can work together across these different industries to really kind of optimize what generation of feedstock we could all be using so that we're, you know, it's very much EMF, we're continuously cycling these in the most optimal way. I think then we don't even have to talk about this black or white situation of, are we going to use bio? Are we going to support the bioeconomy or not support the bioeconomy? We're then instantly having a much more complex and detailed, sophisticated conversation about how we can meet the needs of a growing society in a way that don't harm the planet, but rather stay within the safe operating space.
Okay, so if I mean, that sounds like a massive opportunity, and it makes a lot of sense. What do we need to unlock that then? Is it a case of, I was trying to put myself, as you were speaking, in the shoes of an entrepreneur or a large business even that says, okay, I want to use some, I don't know, second or third or fourth generation biomaterials next week or next year. How would they get started? I mean, is there like a marketplace, or what would you want to see in place to get that started?
Yeah, that's a really good question. I think there's a lot to be done in this space. I actually think it's a really underdeveloped opportunity area, but the first port of call is to make the invisible visible, right? So this urbanization trend, this global urbanization trend, we're all going to live in cities in the near future, I think is a really huge opportunity area where we could say, okay, we're all centralizing or densifying this particular place. Now, how do we make more visible the resources that we have available, and for what and for who? So last year we talked about Materium quite a lot. And one of the projects that we're working on now is this European-wide initiative to look at how to produce products from biomaterials focused on unavoidable urban food waste. If you look inside our cities, food waste is a huge, consistent waste stream. Now, I completely agree with Brian that avoidable food waste is something we should be focusing on trying to minimize completely and just kind of eradicate from the system going forward. But there will always be unavoidable food waste. In Amsterdam specifically, which is where we're starting, we produce 31,000 tons of unavoidable food waste on an annual basis, and it's all being incinerated at the moment. That is eggshells, coffee grounds, vegetable peels, seashells, and the like. This is exactly the material palette that an organization like Materium starts in order to generate new materials for product design, industrial design, and so on. You know, we can produce fiber, castable materials, plastic alternatives, all from this extremely rich resource that we just didn't really understand it was there to that size before. So in terms of what we can do, I would and will from this point forward push every single city politician that I come across in Europe to say, you have to tell people what waste streams are available, and you have to tell them when they're available and where in the city. And then you've got to make them accessible rather than having this beeline to the incinerator. Create these hubs where an entrepreneur like me, a material designer like me, gets an alert. I want an alert every time a certain weight of orange peel gets produced in my city, and I want to know where I can go pick it up.
Brian, you mentioned earlier, I mean, I also I'm looking for that the tons of orange peel is. So if you come across the app, then just send it my way. We can. Ryan, you mentioned earlier about some targets or some measurement, some scientific measurement around biomaterials. Did I miss that? So a project you've been working on.
Yeah. So the idea is essentially if you're taking the planetary boundaries as a starting point, that is to say that we have limits in the impacts that we can have in the planet, that we have limits with the amount that the planet can produce. We understand this on a planetary level, but we need to downscale this to something that's operationalizable. And just really shortly, the planetary boundaries means that there's 9 areas how we can measure the Earth system. And these are dynamic and interrelated. And as some of them push towards out of a safe operating space, we enter into a sort of area of increased probability of irreversible systemic shifts. The big one at the moment that people talk about, for example, is the Amazon shift, where it ceases to be a self-sustaining rainforest and might shift to a tundra if we go above a certain additional degrees due to climate change. But there's lots of them, melting glaciers, these sorts of things. So to avoid these, we need to understand how much impact we can actually have. Everybody understands this in the context of climate change, where whatever 440 parts per million or whatever it is to stay well below 2 degrees or 1.5 degrees. We can also think about this in the same way for biodiversity, for nitrates and phosphates, for water use. And at the moment, these are conceptualized at a planetary level. These really need to be downscaled to a scale that's operationalizable. So meaning if I'm a company who's into orange peel, or if I'm a country who's interested in a certain resource, I have to know how much of that resource can I actually have. And why this is really important for the bioeconomy is that if we're really going to transition to a bioeconomy and use these bio-based materials for supply chains, for all the materials that we need, we also need to know that they will be available to us in the future. So we have a pretty good measure on what fossil resources are available to us. Whatever we can say about them, we know that they're there, and we have a good idea about the cost of extracting these resources, even if it's increasing or whatever. But for bioresources, it's a living system that's producing them. So we really need to have a good understanding of how this is working, and understanding how much it can take in terms of impact, to make sure that we can continue to extract the resources that we need. And that means at the level of countries and regions, indeed at water basins, depending if you're talking about water. We need to understand and set goals in accordance with this.
Well, that's kind of where I was heading with that. That how much can an individual as a business be expected to be tapping into that massively complex global system, and when it's almost seems more complex and unpredictable when you're dealing with bio stuff. I don't know if that's fair. I mean, but I guess with your fossil fuel analogy, it maybe is true. But that doesn't sound like a necessarily particularly accessible way to start using biomaterials if you're conscious that you might tip the planetary balance off just by using too many orange peels or something like that.
Yeah, I mean, as an individual, I think obviously we don't have too much individual impact or leverage influence in the structural system, but we can also, when we consider ourselves as consumers, make decisions that are favoring one option or the other. For businesses, I think it's a question of scale. How big is your business? The bigger your business is, the more of I would say, responsibility you have to think in this way and to source the materials that are, representing ecospheric integrity. If you think about businesses now, I hope a lot of business owners are thinking about their climate impact. And I mean, we're a little bit down the road here, because right now we're really working on developing the methodologies for assessing these things, and the scientific community is really working intensively to understand what these targets should be at these different scales. And we really have a responsibility to make this information visible, digestible, and actionable. And so at the moment, business owners should, I think, get their head around these ideas and understand that this is a way that we need to think as a society, which touches on, I mean, essentially, Joe, what we need is a cultural shift towards thinking more holistically, systemically, and responsibly about the materials that we're using as businesses, as individuals, as consumers, as policymakers, and indeed for the scientific community too.
Thanks, Brian. Just one more question from me then. Liz, you were saying earlier that in some industries they're predicting maybe up to, I think it was 22% increase in the use of bio-based materials. Do you think that when we think about all the stuff around us, the stuff that we make and use every day, do you think that in the next few years, most of the shift will be visible, like the changes in the materials that go into our phones and clothes and homes, or will it be invisible, like to do with chemicals and heavy industry and things like that?
I think it'll probably be a little bit of both, but if you do look at the way that these sectors are evolving, one of the largest consumers of biomass is indeed the chemicals sector. Now, one of the biggest products of the chemical sector is something we engage with every day, which is plastics. Almost all of our plastics, of course, are chemically derived. And that's one of the largest visible things that people are engaging with. And I do think that what I would call to make much more visible, actually, from a kind of consumer standpoint, if that was your question, is the passport of these products and how they're being produced, where, by who. How does a consumer actually know what to do with them at the end of you wanting to use it, right? These are the things I think that really need to become far more visible and far more accessible to consumers. Like, for example, the Science-Based Targets Network, I think, is a huge, momentous milestone in industry. But as a consumer, do I necessarily need to engage with it? Probably not. I mean, if you're interested in it, for sure. And there's lots of outlets out there in order to engage with that discourse. But you don't necessarily need to understand every single gear of this growing ecosystem, but you have a right to understand exactly what materials go into the products that you're using, where they're coming from, the kind of impacts they're having on the planet and certain populations. And you definitely have a right to make a decision about how that material gets processed after you no longer want it, right? Whether it does stay within your city and an entrepreneur can use it to produce a more circular product that can be used for 3 more generations of that material's life, or whether it should be going straight to incineration or getting outsourced in order to be downgraded. I mean, we've bought these things in the first place. We should have a right to hold these companies to account.
Liz and Brian, thank you so much for joining us today from your lovely red sofa in Amsterdam and telling us about the bioeconomy. Thanks for joining us at the DIF.
A pleasure.
Our pleasure.
So the biomaterials, the bioeconomy, it's a hot topic. You'll be hearing more about it at the DIF this year. It's a big deal and it sounds like it's on the horizon. So get clued up. You can find out more at Metabolic and at thinkdiff.co. Thanks for joining us for this DIF session. We're broadcasting for the next few days, so stay tuned at thinkdiff.co. Bye-bye.